Okay, so question 21 is looking at rationalising surds, but we've been given the answer so we can check that the answer that we get ends up being correct. So we're trying to rationalise 3 plus root 2 over 5 plus root 8. So whenever I'm rationalising a denominator that looks like this, I need to multiply by something that's technically equivalent to 1, so it doesn't change the fraction, but I just need to change the sign that's in the middle there. So I'm going to multiply by 5 minus root 8 divided by 5 minus root 8. And then it's just like multiplying fractions, a little bit more difficult, but we've got 3 plus root 2 multiplied by 5 minus root 8, and then that's over 5 plus root 8, and then multiplied by 5 minus root 8. Okay, and if I do those expansions separately, I'll pop them over here. So I've got 3 plus root 2 and 5 minus root 8. If I expand those out, same as expanding brackets, I've got 3 times 5, which gives me 15. I've got 3 times minus root 8, which gives me minus 3 root 8. Then I've got root 2 times 5, which gives me plus 5 root 2. And then I've got root 2 times minus root 8, which gives me minus root 16. Okay, if I go through and simplify that a little bit, because we know the root 16 is going to be 4. I also know something about the square root of 8, that splits into 2 times 4 to get a square factor. So I'm going to rewrite this as 15, take away 3, and then that's going to be root 4 times by root 2. Can you see there, I've done 4 times 2 to give me that 8 that's in there, and then plus 5 root 2, and then take away 4. Again, a little bit more simplifying, so I'd have 15 take away 3 times root 4, root 4 is going to be 2, so we've got 6 root 2, take away 6 root 2, plus 5 root 2, take away 4, and then simplify that a little bit further. 15 minus 4 gives me 11, and then minus 6 root 2 plus 5 root 2 is just going to give me minus root 2. So that was a long method to show you the expansion of the top of that fraction, and at the moment 11 minus root 2, 11 minus root 2, the top of our fractions are end up being the same, so we're along the right lines at the moment. Now if I look at the bottom of the fraction, I've got 5 plus root 8 and 5 minus root 8, so I'm going to expand that out. Same again as expanding brackets, so I've got 5 times 5 is 25, 5 times minus root 8 gives me minus 5 root 8, and then I've got root 8 times 5, which gives me plus 5 root 8, and I've got root 8 times 1 minus root 8, which gives me minus root 64. You can see here that the parts that I've highlighted, minus 5 root 8 and plus 5 root 8, they end up cancelling each other out. So I end up with 25, take away the square root of 64, which is 8. 25 take away 8 gives me 17. So then I've got 11 minus root 2 over 17. That was my denominator, and that was my numerator. Put them together, and I end up showing that that can be written as that.